Hi everyone! In this video, we will compute the z-value for one population mean with a known standard deviation. A fitness tracker company claims that their new model has a step count accuracy greater than 95%. To verify this, 50 trackers are tested for step count accuracy. Determine the critical value for a one mean z-test at the 1% significance level if the hypothesis test is right-tailed, where the alternative hypothesis is mu is greater than 0.95. The alternative hypothesis is where mu equals 0.95, or the 95%. The alternative hypothesis tells us which type of tailed test we do, and in this case I have a greater than sign. Greater than numbers are larger and form on the right side of a number line. It also points in the direction of the tail of the normal curve for our hypothesis test. Drawing a normal curve helps visualize the test that we're working through. And so here's our normal curve. We are working on a right-tailed test over here at a 1% significance level. This 1% significance level means that the area under the curve to the right is our 1%. Let's go ahead and change that to a decimal. And so we move the decimal place 2 place values to the left, making the area under the curve on the right 0.1. We are looking for the critical value where this cuts off and where we could say there is sufficient or not sufficient evidence to make a conclusion about our hypothesis test. Another thing to note is that the population standard deviation is known, which means we do a z-test. If that's not known, then we do something called a t-test, and we'll do that later on. We have several ways that we can identify the critical value right here that will be our cutoff for the significance level of being sufficient evidence or not to make the conclusion about our hypothesis test. We could estimate with the empirical rule. We could also calculate with our calculator, but in this case, we have a table to our left over here with the significance levels for our z-test. And our significance level is 1%, and changing to a decimal is 0.01. So we're going to go look at our chart and find the z for 0.01. So here's our significance level, thus giving us a critical value of 2.326. This means that our cutoff, or the critical value of 2.326, is 2.326 standard deviations above the mean. And because we're a right-tailed test, it is in the positive direction, so it is positive 2.326. So let's go ahead and list it out as our final answer, that the critical value is 2.326 standard deviations above the mean. And now we're all done.